that we have, as well as a larger workshop that we are planning for later May or in June. We're still nailing down the dates, but that's sure to be very exciting. And so we hope that this little seminar series will be an introduction for all of you to get a sense of what digital health is, how you go about developing it, and how you go about evaluating it in preparation for this workshop. So, without any further ado, this is Susan Moore.
Thank you, Bethany. I really appreciate that introduction, and I appreciate all of you being here and online for our conversation today. The way I usually do presentations is that I encourage people to ask questions as we go. I see no reason to change that up today, but there will also be time at the end for people to ask questions or dig deeper into any area that you might have particular interest. Bethany mentioned that this is the first in a short series that we're doing in this spring semester. And I've listed the different subjects of the talks and the dates for upcoming talks after today. Obviously, today is February 7th, and I'll be walking us through an introduction to the topic and to the field. And then in March, Dr. Sheena Bull will be presenting on common study designs for evaluation and validation in mHealth research. In April 4th, we'll have Gabriel Camargo from Ingenious Softworks, CEO of an external developer company, will be presenting from the development perspective on key considerations in mHealth solution design. Evidently, we can't hear me, so hopefully we can now. All right. And then on May 2nd, we'll close the series with a discussion and short presentations from some of the people who are working in the field and their different studies and the results that they've had. And then, as Bethany mentioned, we'll have a workshop to follow. It'll be a 2-day workshop either in late May or early June, and that'll be focused on team-based science for mobile and digital health. For today, we have some learning objectives, both for today's discussion and for the series overall. What I am going to focus on today is providing an understanding of some of the basic key things that you need to know to engage in high-quality research in the field of mobile health. And for the seminar overall, the idea would be to come away with that understanding, come away with an understanding of the different study designs and types of studies that are available, to be familiar with what it takes to collaborate with industry partners and some of the best practices around that, and then to have a sense of some of the common pitfalls and some of the things that can make your projects go well so that hopefully you can avoid the one and pursue the other. Topics we're going to go over today, just a quick overview. I'm going to give some definitions to orient us to the field that we're discussing and talk a little bit about the impact of the industry sector in this particular field. Talk about what it takes to plan good research projects for mobile health, and then finally touch on funding, both how to secure funding for your projects and how to sustain your projects after the grants are done. I always find that's an area of great interest among people that I discuss with. So first, a little of the basics, and we're going to talk about health IT versus health informatics, because this always comes up. So health information technology, which HIT or health IT, refers to the actual technology solutions. We're talking about the systems, we're talking about the solutions themselves that are used to store, retrieve, to access information, to share and send information, and to manage knowledge. Informatics, in this case health informatics, is the science. So it's the study of how the information is managed, stored, used, transmitted, so forth and so on. So a core distinction to remember, because it will come up in your grant review panels if you get this wrong. The technology is the tool, informatics is the science. Another term that comes up a lot and more often recently in the field is talking about digital health. You will often hear mobile and digital health as terms used fairly interchangeably. And there's a lot of truth in that. They're not entirely identical, but there's a lot of overlap. So what I've put up here is the FDA's definition of what digital health is. And why it matters that the FDA thinks that's what digital health is because they're the ones who govern the use of medical devices. So when you have mobile health devices that intersect with the medical field, the FDA is going to be pretty important to your work. So the broad scope of digital health includes mobile health, but it also includes HIT. It includes wearable devices, which I myself would classify under mobile health, but okay. It includes telehealth and telemedicine transmissions, and it also includes the field of personalized medicine. Narrowing that scope a little further, to what we're focusing on. We're focusing on the mobile aspect of that work today. So mHealth, according to a consensus definition from the NIH, is the use of the mobile devices and wireless devices to improve health outcomes, health services, and health research. This is not a small area of the field or area of the market. There are over 5 billion distinct individual mobile accounts in use worldwide, accounting for over 85% of the global population. There's a lot of work to be done here, a lot of potential in this area to reach people in mobile ways, through mobile means. Mobile health has a number of different spheres of influence. You can have mobile health applications, as you might think of as apps on your phone, things along those lines. You can have devices related to mobile health. Things, glucose monitors would be an example. Sensors, Fitbit and activity trackers use sensor-based technology for mobile health. Communications, either unidirectional or bidirectional, back and forth, often used for health promotion over mobile means. And of course, let's not forget the mobile data. I mentioned that this was a fairly large potential area. It's also an area where there's a lot of money involved. The growth of the market sector in mobile health, the growth of interest here and investment here is incredible. You can see that from 2010 to 2015, we grew about 400% in funding involved just in the mobile health sector of this market. We're anticipating a market value in the billions by 2020, so it continues to rise. There's a lot of possibility here. And I keep focusing on that because there's a lot of work here, but there's not necessarily a lot of good research here yet. And that's where the work that we do is so critically important. Everybody's probably heard the saying, there's an app for that. It's more true than people may realize. So this graphic is from late 2017, and it shows the distribution of apps available in the most common app stores. So the tallest one, the biggest one, is Google Play with 2,800,000, followed shortly by the Apple App Store with 2.2 million. Then a significant drop down to Windows for almost 670 million. Then Amazon, a fairly new entry into the field with its own app store, and 600,000. And then finally, hanging on at the end, the system that refuses to die is BlackBerry with just under 250,000 things still available in their store. So that adds up to over 5 million apps currently available. In terms of the overall market growth, not all of those are mHealth apps, but mHealth apps and mHealth products are growing faster than the other sectors of the market. For the first year, the first time actually, growth has slowed in this market overall. At the end of 2017, market growth increased by only 6% as compared to 11% increase the year before. But you'll notice that 9% growth overall among the subsection that refers to mHealth. And so that's still, addressing and beating the market. Why this matters in terms of, why do we care about the market growth? Why do we care about reaching people via apps? Why does this matter? Because on the average, individuals spend 5 hours a day staring at their phones, engaging with apps, engaging with email. People in the room are doing it right now. That's part and parcel of how this works. 5 hours a day. There's a lot you can do if you can capture eyeballs and interaction in 5 hours a day. A lot you can do for health promotion and health management. This breaks down the mobile health app sector a little bit further. So you'll see a 26% drop in things focused on nutrition, almost 50% increase in things focused on fitness content, and 11% on things for workout tracking and weight loss. But the one I want to draw your attention to over here on the left is 0% change in growth in medical and general health. There are a few different reasons for that. One of them is that I mentioned the FDA's involvement previously. That's part and parcel of it, because anything that gets involved in medical service provision or affects medical management is more likely to be subject to oversight by the FDA, and that takes longer to get through that process. So a lot of the people that are developing in the market sector are less likely to go to that unless they have a very good reason to. Another factor is, and this is a factor that is really important for the people in this room, is there's a lack of evidence driving adoption, and we're going to come back to that. Other thing that's important though about this is that health apps and medical apps tend to have higher retention. So one of the big challenges in using mobile solutions and mobile health solutions is that you'll get people to download something. They'll try it, or they might download it and not even open it at all. They might just discard it and go on with their lives. These data show after 30 days where on the spectrum people are in terms of retaining. And the things highlighted in red boxes are health, fitness, and medical applications. And you'll notice that those are, if you further to the right is better, is the more people that continue to use it after that 30-day period. So you'll see that this area has the potential for not only adoption, but retention. Talked a little bit about pace of development in the industry, but I want to highlight that in comparison to the pace of development in research. So traditionally, we all know that the idea in research is that it takes 17 years to go from research to practice with things that are discovered and things that are innovations and interventions and inventions, all three. Moore's law, Moore is not me, this is Gordon Moore, who worked for IBM and Intel way back in the day, is that every 2 years, overall computer processing power doubles. That allows things to get smaller, that allows things to get faster, that promotes mobile development. 2 years and 17 years leaves a 15-year gap. And the result of that 15-year gap is that when you look at the evidence of all of those things that are out there, as of middle to end of 2016, out of all of those apps out there, all of that growth, 113 had an evidence base demonstrating their efficacy, demonstrating that they worked, demonstrating that there was some actual value out there other than, oh, I got 5 friends to test this and this is going to be awesome. There is a significant opportunity here for people interested in doing good work in the field. Over half of apps have fairly limited functionality. They've hit on one thing, maybe a broadcast thing, a promotion message, information sharing, but less in terms of information management, less in terms of other areas of mobile health. And in terms of connectivity and interoperability, well, it's very popular to connect or have some sort of feature on your app or on your solution that'll connect you to Twitter, to Facebook, or to some social media network. When it comes to getting that information into the healthcare system, 2%, only 2% have managed to cross that barrier. And we're going to be talking a little bit more about that too. This matters because healthcare is a complex adaptive system. This matters because when you make a change in the healthcare system in one space, it can have unintended consequences in another area. And that happens. How many people have seen experience with, say, putting an electronic health record in place? A couple people in the room. For those of you that have, how many times did that go right 100% of the time when you started? Yeah, that would be nobody. Healthcare professionals are risk averse. They're right to be. They're not only dealing with things that have to do with their day-to-day business operations, they're dealing with lives. If something breaks in healthcare, people may die. Risk averse is a good way to go. But what that means is that if there's not evidence saying here is something that's going to work, there's not really much reason for somebody to adopt it. So if something's going to destroy the way the work is done, if something is going to destroy care delivery, if there's just no evidence that it has value or potentially could have a good impact on the health that you're trying to do, many healthcare professionals and health systems will actively run away from it. Mobile health research can help change that. So usually what happens next is you have an idea. You have an idea for a project, you have an idea for a new solution. What comes next after that? There are a few core project components to make sure that you have a good research project in place and make sure that the work that you do is going to go as well as you can expect, and then it's going to be sound, and then it's going to be sustainable. These elements are the team that you involve in your work. They are the design, and I mean both the design of the solution that you're studying and the design of the study itself. The data, how you collect it, how you store it, how you share it, how you manage it, and whether or not you can get it in and out of the system, the mobile health system that you're working with. And finally, of course, because nobody rides for free, the funding, both current funding and future funding for sustainability. When I talk to people about doing mobile health research and I say, well, who do you have involved with your team? You know, who's part of your project? Very often what happens is they name 3 clinicians, a research assistant, and they have a line item written down for, and somebody to develop. It's a good start, but that's not sufficient not to have a really, really good project. You need somebody in mHealth research who has that clinical subject matter expertise. Very often this is the PI or the person who's got some sort of idea about how the research project could change the way healthcare is delivered or could change health outcomes. But you also need somebody who has some experience in software or hardware development, depending on if you're working with an app solution or more of a device solution. And that area encompasses people like your actual programmers, those who are going to be writing the code or building the device, the people who are involved in the design of it as the solution interacts with the user. So user experience is the UX and user interface is the UI. Because no matter how good a solution is, it can be the best thing in the world. If nobody uses it, it's not going to do any good. You need another common role in that area is what's called a business analyst. These are the people who get involved in asking questions to make sure that the solution that you're looking to study actually meets all the needs and does all the things that you expect it to do. It's a structured process of identifying those requirements to make sure that something is going to work as you need it to. And then finally, a project manager, equivalent to a research project coordinator, who's going to help sort of, herd the cats and keep everything together, on track, on time, on budget. You need somebody who has some knowledge around health IT or health informatics, thinking about those data areas, the collection, the storage, the interoperability, the exchange. How is the data in your project going to be managed, especially if it's inside of an app or device? How are you going to get it out? What are you going to do with it? And then, last but never least, something that very often people overlook is it's very, very valuable to have an implementation science perspective involved. Because as I said, it's no good if nobody uses it. Implementation science is how you get from the lab into practice. That's how you look at measures of adoption, measures of sustainability, measures of reach, measures of expected adherence to, does it work the way it intended, or does it interfere with the workflow and things have to be done a different way? Having somebody on your team who understands components of all of these disciplines gives you a very strong team. When you're thinking about mobile health research and when you're thinking about solution design, solution use, and what it is that you're going to be studying, you need to think about who's going to be using it. And that includes not only your patients, that includes not only members of the community, the consumers who might be targeted in the function, but also caregivers who might be involved in the care process somewhere, your clinicians and your other health professionals. You need to think about user interface, user experience, and you need to make the decision whether you're going to build something brand new or whether you're going to choose from that library of existing products out there if there's something that might already meet the need. Making that decision can be really hard. Lots of times researchers in this field, you're researchers because you have new ideas and you have new things that you want to try and test. But there are cost factors involved in how much it may take to build something from the ground up all the way to where it's functional in the way that you need it to be for the work that you're trying to do. And you need to think about whether or not the solution fits the intended user base. So, who are your intended users? In the general population, this has been proven time and time again according to diffusion of innovations theory, which was originated in the 1960s in the field of agriculture, but has been discovered to be especially applicable to technology development and technology use. Your intended users are going to fall along this bell curve. At the far left end, you're going to have your innovators, about 2.5% of the population. These are the people who line up outside the Apple store for the latest model of the iPhone, right? These are the people who are not only on the cutting edge, but the bleeding edge. They're the ones who want the first of everything. They'll try something new, no matter what it is. Early adopters are the ones who wait for the first patch to come out. These are the ones who are willing to jump in line fairly early on, but they're not going to be the first out of the gate. Then you have your early majority and your late majority, which is where most of your population ends up. And then at the other end of the spectrum, you have your laggards. Laggards are people who are generally, they don't like change, they're suspicious of technology, or they don't have the money to make investments in new technologies as they come along on the early phase. So you need to consider your potential user base by their demographics, by their profiles, and by their needs, because they're all going to fall along the spectrum somewhere. If you're designing something that's only going to be for that 2.5%, it's going to take a while before it goes out through the rest of the population. Another factor that's important to consider in mobile health research and product use is how will your intended audience use your products? How many people here like clicking through 7 screens to get to the field that you need to type a value in? Unsurprisingly, that would be nobody. Nobody ever. It's the principle of the lazy user. You want it to be easy to do what you have to do. If something is too much trouble, it's going to be discarded or never used at all. Developing versus shopping. If you're looking to build your own solution, you need to think about, so there are pros and cons in both of these. The biggest question is the focus of your study. Are you testing the solution itself? Are you trying to learn more about the app or the device or the sensor? Or are you testing how it's being used to affect something? And the app or the device or the sensor itself doesn't matter as much as the downstream impact that it might have on health delivery or health outcomes. If you're testing the solution, or if there's something that maybe there's nothing out there that quite fits, or you need to particularly tailor it to specific needs, development might be for you. If owning the intellectual property involved in the product that you're looking to build is important to you, development might be for you. If you're not as worried about costs, if you have connections so you know that you have the ability to find all the skills that you need, if you're comfortable working with platform infrastructure considerations and all of the different components beyond the product itself in hand, development is maybe a good choice for you. On the other hand, if you're more interested in studying, for example, how can this thing affect diabetes self-management? How can a solution like this affect how I deliver care? Finding something that's already out there might be for you. It might not be an exact fit to everything you wanted, but it might be pretty close. You might be able to license it and get technical support for much less than it would cost to build it from scratch. When there's a limited evidence base for those existing options, there are a lot of companies who would really like to be able to say, and the evidence shows my product works because this scientist proved it. There's a lot of opportunity there. Finding those existing solutions can be a little bit more difficult. I think most people who do federally funded research are familiar with the NIH reporter that you can go through and do a search of studies and see what projects are already out there, what investigators are already working in particular areas of the field, things like that. Unfortunately, we have no mHealth reporter, so there is no one place to go and find what the latest greatest is. Generally, one of your best bets is to do searches within the app stores themselves, design your keywords in advance the same way you would do as if you were doing a literature search on a new topic. Look at customer reviews, look at app descriptions for details. Here's just an example looking in the Apple Store with a search on diabetes apps. This is, I think, page 1 of 9 that came up, but it just gives you an example of the sorts of things that you might find. You'll also, if this is an area that you're particularly interested in, Google will be your friend in terms of searching for new releases, looking for investment companies, do a lot of announcements of new products that they have going on the market. Health information technology news sites and sources will talk about things that are up and coming, and then there are a lot of different review sites. You can also engage with your community, and that is something that I'm hoping that this seminar series will be able to bring together a community of researchers on this campus to say, look, I need to do this and I can't find anything out there. Have you heard of anything? Do you know anybody who's doing work in this area? You want to consider for the research that you're doing the infrastructure that you need and the design that you need. If you're doing work involving mobile phones, you need to think about any carrier-specific limitations. To give you an example, you might think that, text messaging program, fairly simple. Everybody can get text, everybody can send text. Generally, that's true. what not everybody necessarily realizes until you try that and discover it is that the telephone carriers, your T-Mobiles, your Verizons, your AT&Ts, your Crickets, they attach their own hidden codes to the beginning and ends of messages to essentially show the envelope, the packaging around the message. If the system that you're using doesn't know how to decipher those particular codes, your message ends up looking like garbage. So having considerations, technical considerations like that, what's required to do this type of work in terms of infrastructure? If you're looking at building something, how do you want to design it? So I have here native, responsive, or hybrid design. And this is particularly applicable to mHealth applications, so new apps for the phone, right? Native design is something that's specific to an operating system. It's designed to take advantage of all the particular characteristics of whether it be an Android, whether it be iOS, or whether it be a Windows phone. It can link in with those specific components because it's built to be a package that exists on the device and doesn't necessarily have to connect to anything outside. Responsive design is more likely to be connected to external networks because it adapts itself in display to the device that you're using. It's kind of like the idea of having a web page that displays differently on every device. You can take that a little bit further now and use different components that are built into mobile languages to do something more than one page display, but it still has that same idea of it comes from a central server and it adapts its form to the object with which you are viewing. Different platform-specific limitations. So if you're going with a native design and you're building for an Apple product, it takes an entirely separate build to build something for an Android product. You need to think about policies for how you want to distribute the thing that you're developing. And the thing that people most often forget, you need to think about the supporting infrastructure for it. So I mentioned, think about how is the data collected, how is it stored. If you have the app on the phone, where does the back end live? A lot of mobile health research can be done using the large cloud services like Amazon Web Services, Microsoft's Azure, and the Google Cloud. But you have to think about building that into your project and making sure that you've accounted for that in terms of, just membership fees, basically, and service delivery. You need to think about technical support, not only who's going to support you if something goes wrong, but if one of your users in your study says, I'm getting this very strange error, or this is broken, or why is it not working? Do you want to be tech support? Do you have a team identified who can do that? Are you working with somebody existing who has a support division that can answer those calls? It's an important component. We talked a little bit about how that 2% connect to systems outside of social media. This is the concept of what we call interoperability, and that's the idea of information exchange between operating systems, between large structures, between one EHR to another, so between Epic and Cerner, between your device and the electronic medical record, through different sorts of interfaces. API is application programming interface. Think of it as something that helps to bridge that gap so you can get information across one to the other. This may be exchanged directly through systems that are plugged in. It may be exchanged over the internet using cloud-based services. So all of this leads to, you need to think about, do you want your solution to connect to these external systems? How should it connect? And then who owns and manages and regulates the data storage? This is the area of data governance. I know I'm throwing a lot at you, but I did say this is an introduction and an overview. We will be able to dig into all of this more, and I'll help provide resources for that. But data governance is that structured regulation and set of agreements around how that data is shared, owned, and managed. Very important if you're working with collaborators. Say you're working with 4 different universities. One of the universities provides the server backend and the tech support for the mobile health solution. It's going great. Project ends. They say, well, we've got it on our systems. You don't need the data from that project, right? Some of these things you have to think about in advance and work out early on. These make your project stronger and help you avoid pitfalls. Some things that you're going to run into when doing work in this area is the SMART standard. SMART stands for Substitutable Medical Applications and Reusable Technologies. The idea is that you want to build something that's well suited to work across systems, not one-off solutions that are off in the corner and never used again after the next upgrade, whatever type of upgrade that may be. It's open platform and open source. It intersects well with the Argonaut project, which is a private industry collaboration. It involves 5 of the major EHR companies, a number of healthcare systems, Intermountain Healthcare and Mayo are among them. And the idea is that they're advancing the adoption of using interoperable standards to help promote the idea that data should be able to be shared, and to get away from the idea of building solutions that are linked only to one type of EHR or one type of operating system or one specific thing. And then finally, the term SMART on FHIR. FHIR stands for Fast Healthcare Interoperability Resources. It's a new communication standard. So in a clinical setting where you might have multiple types of clinical systems, maybe you have something that's tracking information in the ER, and you have a different system that's managing your surgery information. And then you have an overall scheduling system, and you have an overall system for storage of electronic health record data. You have all of these different components, right? These components talk to each other through communications protocols that use a standard way of sharing information. FHIR is the next level up-and-coming communication standard. And it's important to mHealth because it is particularly designed to help support the exchange of information from mobile applications and mobile devices with clinical and larger data structures and systems. You'll want to consider in your work, and more specifically, we'll just touch on this lightly because it's more important at the end of your work after you go out from under the research umbrella and into practice. You're wanting to consider how the law, how regulations will affect what can be done with your work. Personal experience. I work at Denver Health in the Center for Health Systems Research there, and I was working with a team of clinicians and a good technology group on building an automated solution for bidirectional text messaging for diabetes management. So this particular solution would take messages, it would send them out to patients requesting them to send their fasting blood sugars back in the morning. The patients would reply with the number. We would reply back saying that we got it. We would take that information and incorporate it into a system that evaluated against the standard. So if patients replied back and their blood sugar was too high or too low, the system flagged it for action by a nurse who could reach out and say, how are you feeling? Did you mistype that, or is something going on? They could titrate medications. They could do that help with that sort of diabetes self-management outside of the clinical, the context of the clinical visit. Sounds great, right? We did qualitative work with the patients. They loved it. We were able to get the information to the point of care. That was great. Providers were able to see what was going on in between clinic visits. We said, fabulous. We did the work, we finished the research, we looked to bring it to scale, and we ran into the law. Turns out that there are some things that you can't do. The FDA regulates some of it, and it specifically does not regulate some of it. For example, it does not regulate anything that interacts with the EHR or involves health information tracking. HIPAA regulates more. And one of the things that relates to the project that I was just mentioning is that HIPAA requires, if you have an automated system doing your information exchange, the information must be encrypted from end to end. How many of you use something on your phones that ensures that all of your text messages are encrypted? The entire room is filled with people shaking their heads no. It's a bigger challenge. It puts in a big barrier to entry, a barrier to operation for the patient population that we were trying to reach. And so our beautiful evidence-based solution fell apart right there because we couldn't bring it to scale in practice because of the law. So you want to think about what your solution would ideally be used for and early on, and how you might address some of these challenges before you have the experience that I did. We turned it into a system that generates one way, and it includes no PHI, so that we're able to continue using it, and patients still get the benefit, but it was a change. Yes? Yes. Yes, it does. Especially if you're working in a healthcare system or with a healthcare system, patients can say, "No, I'm cool with that. I'm happy. I want to do this." And HIPAA says, "That's nice. We're going to actually hold the covered entity, like in this case, the health system, to that higher standard." So that's one of the things to be aware of. Another thing is to be aware of, particularly for mobile devices that are exchanging information, something called the Telephone Consumer Protection Act. Most people are aware of this in the vague context of the do not call list. This act, combined with something called CAN-SPAM, is the one that keeps keeps marketers from being able to bombard you overly much with information that you might not want to get, that you haven't asked for and don't want to receive. It does apply to text messaging. And there's uncertainty whether or not it applies to message prompts. There's some exemptions around healthcare-related messaging, but the area is still developing. So it's important to have a sense of what might be going on in the field. CU Innovations can help with some of that as a resource to people here on campus. As I mentioned CU Innovations, I also want to mention considerations of intellectual property for the work that you're going to be doing, because it's a little different from creating a drug or a standard medical device when you're working in mHealth. For one thing, software code, you cannot patent software code. You can copyright it. You can sometimes patent software products, but that gets a little bit tricky. You can license the use of an mHealth product. That covers use and distribution. The copyright covers the content. So if you're creating content, say customized message libraries or particular guidelines to be administered and delivered through a mobile solution, all of that content can be covered by copyright, but you can't patent the content. You can trademark things, and you might want to consider if the design of your solution has like a particular look, a particular feel, if it has a catchphrase, if it has a logo. These are things that you can protect. You can patent some apps, but the law is really not clear on this. There are 3 major legal cases that have addressed this in 2008, 2012, and 2014 is the most recent. And basically the first one, the Mayo case said that if you're going to patent something, it has to be more than applying a natural law. This is important for a lot of things that are taking existing concepts and trying to create an application of them, which is very common in the mHealth space. The Alice case said that while the abstract idea isn't patentable, an inventive concept that transforms it is. But then in 2014, the Bilski case said that something that's a machine-based method or a process, like an algorithm, is not patentable just because it's machine-based, just because a computer calculates it. So this is a little bit of a complicated area, and I urge anybody doing mHealth research, if you think that you have something that could be protected, talk to CU Innovations. Talk to them early, talk with them often, because the way patent law in the United States works is that it's not the first person who invents it who necessarily gets the intellectual property. It's the first person who files the application. And there, especially in this fast-growing field where there's a big market share, there are a lot of companies out there that just try to get the idea and file. They want to be the first to file to end up with that ownership. Kevin.
I spoke to some patent attorneys at a recent medical device thing, and they told me that, of course, being in a position to defend that patent is enormously expensive and oftentimes not worth getting it in the first place. And so I said, well, what was the point of it? And they said, if your idea is going to be acquired by somebody, the acquiring company might see greater advantage than having to
if you've already gone through.
Having to defend it expensive.
Yeah. Which to the point, talk to CU Innovations early and often. Think about how to protect the work that you're doing. Finally, to the thing that I know is probably of particular interest, funding and sustainability. One of the most common questions I get in this field is, how much does it cost to build an mHealth solution? How much does it cost to make an app? The answer to that question is so wildly variable. It depends on the features that go into it, depends on data storage considerations, it depends on so many things. I've seen quotes for as low as 3,000, as high as 300,000. I've heard of quotes for $1 million and more. Although if you get one of those, I would advise you to talk to other sources to see if somebody can do better for you. It depends on how many cycles of development you're running through, how much testing, revisions, upgrades, depends on personnel. So the average cost is hard to determine as a line item. So this is important, and again, in your team, engage people who have expertise in these areas who can give you realistic estimates so that you can plan accordingly in doing your research. You want to consider your funding sources, and there are a variety of them. Private funding, state funding, foundation funding, federal funding. A lot of it, we're not going to spend a lot of time on private funding considerations because I'm not an industry representative, I'm not a venture capitalist, and I'm not an angel investor. The difference in the two is that the angels give you the money, the venture capitalists want something for it. Again, CU Innovations can help with this a little bit, and there are also industry groups that can help with this, or I can speak with people who are interested in this a little more directly and provide some more information about that. But that is a potential source of funding for your work. What we as researchers are more familiar with is federal funding. It's gotten a little harder in recent years, but the money is still out there. A lot of times federal agencies will want to see that the app or the solution that you're developing, that there's a plan for it beyond the end of the grant. They will want to see that there's a reason to build something versus using something already existing. And that's where that due diligence comes in, going back to looking at the market and what's already out there. There are particular funding calls from the different agencies that are targeted at technology development and support. Looking for those when you're looking for something to fund your research idea is very important. Some of these are the traditional R-series grants. A lot of them are R21s, which tend to be a little bit more on the novel side and a little bit less likely to require something to have as deep an evidence base. SBIR and STTR funding is a particular mechanism. SBIR stands for Small Business Innovation Research, and STTR is a technology transfer context. Both of these are types of awards that are made to companies, like small business companies, that can be done in partnership with university partners. Usually what university researchers are going to be more interested in is the STTR, because you can be the PI at the university on that project without having to leave the university and go work for the small company. Excellent, thank you. So we have a question that came in online, and that is that one of the things the team struggles with is balancing usability testing and engaging user input into the design and not running out of time so that design itself becomes obsolete. Do you have any thoughts on that? It's an excellent question. And this is where development cycles and iterative development come in. This is where that can be pretty key. There's a couple of major development styles that you'll run into. One is called waterfall development, and that's where you start with the idea at the beginning, and at the very end, you execute the idea exactly as is and as planned. Then you go out and you test it and you find out all the things that you need to change. Another development context is called agile development, and this is the idea of doing development in short sprints, often 2 or 3 weeks, and getting feedback at the end of each sprint. And using that kind of development approach allows you to engage with small groups for qualitative user feedback on as you go through the process of developing your solution. So that way is a way to be adaptive, to incorporate user feedback as you're building something, and be still both responsive to the needs of your research and of the market. Sheena Bull, who will be speaking here next month, is the director of the mHealth Impact Lab that specializes in helping researchers negotiate some of these practices. I can put you in contact with her. I also work in the lab, so I can help with that for people who are particularly interested in addressing those challenges. Speaking of challenges, one of the final areas that funding is available that people don't often realize is through this idea of prize money for developing something in a short sprint, in a quick succession, in a challenge environment. There's a digital health challenge that happens here in Colorado in the Denver area every fall, led by the Prime Health Collaborative, which is a bunch of digital health industry entrepreneurs. But it's not just from groups like that. Health and Human Services has gotten on the challenge bandwagon. They're setting aside amounts of money from anywhere from $10,000 to $250,000 to fund ideas that people put together quickly and send in as prototype products to bring work forward. This one is from December, and it's responding to the opioid epidemic through developing solutions. So this is an area that the federal government is trying to get into to address the research time frame, make it go faster, and provide money through non-traditional means. I'll be wrapping in 3 minutes, but thank you. Other things to think about looking in funding and sustainability is looking beyond the end of the grant, thinking about continuing. What does licensing look like after the grant is done? What do upgrades look like, support and maintenance? If you're working with a vendor, are they going to stick around? And if you come out the other end of your project and you have something unique that you think others might want to use, is there a way to sustain it, perhaps through commercializing it? That is a factor that will always come into play in mHealth. Commercialization is not inherently evil. It is often a way to get supporting funds to keep your product alive and keep your work going. I-Corps at CCTSI here on campus is a program that the university offers that can help you with thinking through some of those ideas. It was originated through the National Science Foundation. It's now sponsored by the National Institutes of Health. It's a team-based short course for innovators who are perhaps interested in taking their research work beyond the walls of the research environment. Applications are currently open, actually, and the next short course will be held in April and then in May, with a 2-day workshop in April, some homework in between time, and then a closing session in May. These courses are offered both in the spring and fall, so I encourage people who have research projects that they're interested in maybe taking to the next step to reach out to I-Corps and see if that's something where they can help you. I know I threw a lot at you, but this is intended to be an introduction and an overview to some of the characteristics and considerations for doing work in mobile health research. I hope that some of this has brought things to mind that you might not have thought about that might be helpful to you, and I hope it hasn't been too overwhelming. Here is my contact information. Please feel free to use it. I'm happy to answer questions. I'm happy to put you in touch with people who can help with areas where I can't. I want everybody to be successful in this area, and I'm delighted that you were here today. We have a couple of minutes for anybody who might have questions.
And please fill out your evaluation. There's a bunch here at the front here. And anyone on the phone, I know you don't have the form, but if you have any suggestions for next time, if you would send those to Brian Ford, we're happy to incorporate suggestions for improvement in the future.
Thanks for attending, everybody.